My real motivation is just that I really want to learn how things work. I mean, I want to know how to solve this problem, right? And I feel like this is a good approach to problem solving because if you want to learn how to solve a problem, you don't necessarily just write the code and call it a day. You want to learn more about the problem. It's very educational and very fun, at least for me.
Welcome to ArrayCast episode 74. My name is Connor, and today with us we've got our 4 panelists plus a special guest that we are going to get to introducing in a few minutes. First, we're going to go around, though, and do brief introductions. We'll start with Bob, then go to Steven, then go to Marshall, and finish with Adam.
I'm Bob Terrio, and I am a J enthusiast.
I'm Stephen Taylor. I know something about APL and Q.
I'm Marshall Lockbaum. I've worked with J and APL and BQN and Singeli and now K.
I'm Adam Botzewski. I started with APL. I stick to APL.
And as mentioned before, my name's Connor. I am a polyglot programmer, maybe not even compared to our guest today, but we'll we'll cover that in a few minutes. Massive array language fan and host of this podcast. Before we get to introducing our guest, I believe we've got 3 announcements. We've got one from Stephen, who we'll start with, and then we'll go over to Adam for the last 2.
Yes, Connor, this month KX released KDB 4.1. It's got some very interesting new features to make it more powerful, like multi-threaded data loading. But you know me, I'm only here for the poetry. I'm interested in the new language features, which include a dictionary literal syntax, pattern matching in assignments and Lambda signatures, and type checking and filter functions, so you can write even more beautifully expressive code than you could before.
Ooh, already on our list we won't spoil the surprise because we don't have any of them confirmed, but we have some attendees of KXCon lined up. But now that you mentioned that, the pattern matching, that was from Oleg and Pierre's talk. They previewed this feature, I think, at KXCon 23. So we will have to get someone, whether it's Oleg or Pierre or someone else from the core KX team, if they would like to. We'll have to get them on because that pattern matching stuff was awesome. Link will be in the show notes. I'll go find the talk that talks about it. They gave a preview of that stuff. I think that one was recorded. I think they were all recorded. Anyways, and stay tuned. Hopefully we'll get someone from the KX core language team on to talk all about these new features. All right. I interrupted. Over to Adam. And yes, 2 more announcements.
Right. So on April 11, there is something called DINA. So that's like Dialogue North America, a meetup. And that's in New York. It's not so much for array programming enthusiasts, although they're welcome. It's really about big commercial systems, small commercial systems, and especially about moving from APL vendor to APL vendor, which is something that can be easy, can be hard, and what can be done about that. I think one thing that's really exciting about that meetup is the speakers. They're all APL experts, and there's a chance also to sit down with them one-on-one. So if that's something, check our show notes for a link to that. And then in the previous episode, I mentioned a reaction video that I had made to the Prog Langcast's video about APL and related languages, and turns out that Prog Langcast just came out with a reaction video to my reaction video. So check that out. Link in the show note.
And I think it might be more than just a reaction to the reaction video, because I guess they did have BQN in episode 4. But
yeah, they say they continue with BQN as well, because they didn't really have time in the last episode to get into that. So
yeah, we as members of the ArrayCast podcast panel and your host, we apologize. The video only came out like an hour ago, and YouTube only notified me of it like 20 minutes before we hit the record button on this, and I only was able to get through 4 minutes, which sounds bad because it sounds like there was an extra 16 minutes in there, but then I had to switch over to a different lecture. Anyways, we will, I don't know if we'll all watch it, but I'm going to finish watching it afterwards, and we might have more to say in episode 75. But yes, links for all of that stuff KX 4.1, the KXCon lecture about pattern matching, and links to the meetup, links to the podcast from Proglane Cast, even though the YouTube channel is Proglane Base, all in the show notes. And with that all out of the way, I am extremely excited to introduce our guest today. I believe her name is pronounced Kamila Szewczyk. She will maybe pronounce me in a couple minutes, or depending on how long my introduction is. And she is an extremely impressive programmer. At the age of 19, she's already an international conference speaker, apparently has been listed on Wikipedia for some crazy programming feats. She knows, according to her bio, C, C++, APL List, x86, 8051, 6502, Z80 assemblies, Perl, Java, LaTeX. The list goes on to mention others that she's comfortable with: Lua, TypeScript, ActionScript, Rust, Haskell, OCaml, and then is learning a bunch of other languages. And this is just the stuff she knows. We will link to her Dialogue 23 talk on the APL array notation. I got partway through watching that talk, and while she was interning at Dialogue, she did a ton of stuff, primarily on the APL array notation, but also she implemented quad diff. She implemented reverse compose, which potentially means we might be doing, tacit 5.5 or whatever, mini tacit episode in the midst of this, and a bunch more stuff. On top of that, she's got like a bajillion projects. We will link to her About Sort of Me website. Also, I don't know how I'm going to attempt, and then once again, Kamila can correct me if I've said it incorrectly. Your online alias you typically go by is Paleologos. And I'll stop there. I'll let her correct the pronunciation of that. And there's so much stuff to talk about, but yeah, maybe I'll throw it over to you. You can correct my pronunciations and maybe give us a sort of brief background on how you have become so accomplished at your age at all of this different stuff, because I am dying to know.
Well, that was just mostly by curiosity, right? It's also what driven me towards APL. It's not like I was particularly interested in array programming or, all the features of array languages that you see. To me, as a maybe 12-year-old, 13-year-old, it was just interesting that it was squiggles. And it was rather compact and code challenges. So I thought that maybe I should learn it to see if it's comfortable to work with. I think it was a great decision overall.
At 12 or 13? Wow.
Yes, I really enjoyed the APL. I think that it really changed me as a programmer. Because I really find myself very productive when I think in terms of very high-level problems, right? And I no longer think of individual steps that I would write in an imperative language to accomplish a task. And instead, I think in a high-level view of what really needs to be done. For instance, I was working on a project which is a neural network that can model JavaScript code. And the point of that was to create a golfing language to be used in PBCG in order to beat, hopefully, all the other existing golfing languages. So in order to train a neural network, you need to have a data set and a verification set, right? And you want to harvest the data set, for instance, using an SQL query to the code call database to get all the JavaScript programs. And then you have to filter them, right? And to me, it seems kind of obvious how you would filter them. But then I realized that if I wanted to write the filter in Java or C, it would be extremely long because there's a lot of criterions, right? Like, for instance, you want to extract the actual code snippets from the posts, which are a CSV file. You want to remove the ones that have too long strings that are generally not very representative of the actual JavaScript program, right? And the APL program that cleans up the whole thing is 9 lines. And I've really never felt as productive as I do with APL. I mean, even if you look at the history of my projects, you'll notice that all the things that I made have been made after my initial exposure to APL. And a lot of the projects that you see listed that don't have the source code attached have been in some ways modeled with APL.
That is very interesting, especially given that you've done projects in assembly, because you've gone from like the most, other than ones and zeros, basically the lowest level of like you need to code in instructions all the way to the highest level. And you're sort of, you've come out of this experience saying that like, I like APL the best by far just because I don't need to think in these like tiny steps. I can think at this extremely high level and understand what's going on under the hood, but be way more productive because I can avoid some of the detail and not spell that stuff out and just work in these high level operations.
Yes, there's actually a lot of high-level operations that you have to kind of execute in your head if you want to write performance assembly code by hand. It's a good but technical example of dividing by a constant in assembly. It's usually done through modular arithmetic with a shifted multiplication. And how do you compute it is basically just a very complicated math formula. But you can write an APL program, and then you feed the divisor, and it generates the assembly program that divides by the given value very quickly.
That's amazing. I mean, and so how you said at 12 or 13 you started messing around with APL and falling in love. Were you like programming already at that point for a number of years, or were you going through some course that was at school that was teaching you a bunch of stuff, or was this all sort of on your own, or like how did you get to this point?
Well, I haven't never talked to a person who could actually program until I was maybe 18, like in person. I've talked to people who could program via the internet. But, well, my first introduction, even before Adam, was on IRC, on the now unfortunately dead Freenode network. There was an esoteric channel where people were discussing like some sort of a weird combinatorics problem. And then I thought, oh, well, they're verifying their computations using that weird language. And they linked with the channel of J Software on Freenode. And I was really keen on learning it, but I wasn't mature enough to appreciate array languages, I think. And
what age was this?
Oh, I don't even remember. That was maybe 2019.
2019. Okay.
Well, it was very difficult for me to appreciate because I was mostly a C programmer. I mean, I've got a very long way since then, but I never really focused on algorithms or how you would write mathy code. I wasn't even that good at math before I learned APL. But APL really gave me the insight into how the theory of computing works. And you could really see this throughout the years in all the projects I've done. For instance, KamilaLisp is a somewhat controversial language, research language, which I've made. And it's built entirely on the premise that I want APL to be a math language. I don't want it to be a computer language necessarily.
Interesting. So tell us more about this KamilaLisp, because I think that was going to be one of the main topics, and I listed it under the number of projects. But yeah, tell us, KamilaLisp, is it a Lisp? Is it an APL? Is it both? What is KamilaLisp?
Jumping straight into the controversy. I was going to say there wasn't any, but you found it.
Yes. Well, initially I wanted to start with something that is a bit like APL, but then I realized that APL syntax is sort of beautiful, but difficult to modify. If you want to change APL syntax, you start adding a lot of stuff that's incompatible with APL, and then you end up with something that's not really an APL either. And I really wanted to avoid the whole syntactic part of APL, which is, well, arguably very important for APL, but not very important for a research project like mine. So I decided to settle with a Lisp framework. So obviously, a lot of the scheme code that you write will be probably valid KamilaLisp code. But KamilaLisp doesn't actually provide you with lists, for instance. It provides you with arrays. That changes a few things, but it's possible to map scheme operations into array operations. And on the other hand, it has tail call optimization, like most schemes. But it doesn't really encourage the Lisp programmer point of view, where you have small recursive functions that accomplish a simple goal, right? Instead of a recursive function, you would probably prefer a reduction or a filter or some sort of other operations like expand, compress. So it's really hard to throw it into any bucket, really. I think that the easiest way to categorize it would be a Lisp-like array language.
So can you talk to us a bit about like what it looks like? Because I looked at the GitHub repo README, and it has a couple examples. One of them is like a SKI calculus with some pattern matching for the SKI combinators, and it looks very, very Lispy. It's got like a parenthesis defun, SKI, variable X, and then a bunch of parentheses everywhere. But then right underneath that, it has a example of quote unquote list operations and point free programming. And this looks very, very different than Lisp. There's not a single parentheses, and you can see what looks kind of like an iota glyph, a row glyph for sort of iota and reshape. and then there's what kind of looks, because it has the APL and Haskell underneath, and it kind of looks like some kind of fork syntax.
Yes.
And some composing. So I'm assuming both of these are valid KamilaLisp. Is that correct?
Yes, that's true. What you're seeing is a shortened version of a KamilaLisp program, because it's something that certain Lisps implement, whereby if you don't want to type like 30 closing brackets at the end of your expression, you could use a backslash to say, there we open a paron, and the paron closes at the next closing paron.
Oh,
Yes.
really?
And the forks in KamilaLisp are like forky trainings in APL. But again, KamilaLisp lifts the whole notion of having only two arguments. So you can have variadic forks, which is the mu recursive. It's one of the mu recursive functions where you compose the functions in a way such that the middle operation of the like standard APL fork gets the result pre-processed by each of the functions that follow it in the fork on each of the arguments.
Right. And that covers both the monadic and dyadic fork, and then any number of arguments, as long as...
Yes.
That is very cool. So that's like a superset of the forks that you get in BQ and APL and J.
Yes. It also implements some proposals from dialog, and I say quote-unquote implements. Well, actually, while implementing KamilaLisp, I have noticed a lot of implementation problems that stem from my design choices that I made previously. I regret some of them.
It happens.
For instance, I've decided to settle on the based array model, which some people might not necessarily agree with. At the time, I thought that the based array model makes a bit more sense for my research project than the floating array model. But then I noticed that I can't really model inner product without breaking a lot of stuff, following Roger's implementation that you can see on APL Wiki. And another problem that I had is, do you know the APL's depth operator that Adam proposed?
The step operator?
Depth.
Or depth operator. I think it's been brought up once or twice on this show, right?
We should probably describe it.
I was looking for confirmation from Adam.
I'm trying to play back all 70-something episodes in my mind here quickly, too.
Whoa, we talked about this. Everyone has to know everything they've said up until now.
The depth operator is just applying a function,
Yes.
either at a certain number of steps into an array from the outermost level, or at leaves of a certain minimum depth, and then you keep going through the array, traversing the array.
So it's a lot like the rank operator, where in the rank operator you say what rank you want to operate on, but in the depth operator you say what depth you want to operate
And
on.
you can combine the two operators for various effects.
Right.
Yes. So you can actually, it's very easy to notice how the depth operator works in the monadic case, right? It's a bit more difficult to notice how it works in the dyadic case, right? Because of all the mappings and different boxing. But the problem was that KamilaLisp has variadic functions. And implementing the variadic depth operator in turn turned out to be an extremely difficult task, at least for me. And so far, I haven't found a convincing model for that either, actually. So I've decided to settle on a depth operator that models the shape of the first argument and then sort of coerces the rest of the arguments to play along, which is, again, not how, for instance, map works, because the map will adapt to the shape of both arguments, right? It will not follow just the first argument shape. But on the other hand, implementing depth the same way as map is very complicated. I'm not even sure how you would do it now, but that includes a small discrepancy. And because it's just a research project where I try to combine various ideas, KamilaLisp is might be a bit confusing to someone who is not familiar with array programming. But I try my best to convey some stuff about KamilaLisp in the small book that I wrote. It's present as documentation in the repo. It's, I think, around 90 pages, and it teaches functional programming and array programming using my language.
This is under the doc. Oh, yeah, doc, and then /content, and there's a bunch of tech files. Is that accurate?
Yes, there should be a PDF somewhere, I think.
Oh, yeah, just under doc/ and then there's a main.pdf.
Yes.
Very cool. I will definitely be reading this. Well, I have two quick questions. Well, hopefully one that's quick, and then maybe the other one's not quick. The first one is you mentioned that certain Lisps do this thing with the backslash that controls opening and ending parentheses. Are there common Lisps? Like I know of Clojure, and I'm pretty sure it doesn't have that. I don't know Scheme super well, but I never came across that. Like, what's the most popular Lisp that does this kind of technique?
I can't name one off the top of my head, but it's very common in cases where we have restricted input. For instance, if you've ever used a TI calculator, which runs TI Basic,
Yeah.
then TI Basic will automatically put the closing parents at the end of the expression when you decide to evaluate it.
Oh, interesting. I didn't know that.
I've seen the same idea in some Lisp. I actually feel bad about not recording which Lisp in order to credit them, but
it's okay. Actually, that makes me feel better because I don't like to think I'm an expert in stuff, but I've touched enough Lisps that I was like, oh wow, I've never. If you were to say Scheme and then I never came across that, I'd be like, wow, I clearly didn't learn Scheme well enough. I didn't go down the Scheme rabbit hole. So that's totally okay. The second question is, so you mentioned that like the depth operator was a lot trickier, if not like you're still struggling with wrapping your head around how to implement that. Are there certain primitives or operators in KamilaLisp, or however you refer to them, that because of the variaticness of functions, you were able to like unlock some like cool functionality that isn't possible in like an APL or BQN because we're limited to only, dyadic functions? Like, do you have any examples of stuff like, because I imagine like you must run across some stuff that like, oh, like this is really cool. Like, for instance, like you can use forks with the two outer functions having any variaticness. I'm not sure if I've ever run across a case where I've needed that, but like that's probably because I know that I don't have access to that. So I'm not looking for that case. But if I did have that tool, it probably would come up now and again. Do you have any examples of that or not really?
Well, I don't really have that bad examples of this on hand, but you have to also remember that the language that you use forces a thought model upon you, right?
Yes. Yeah.
So because you're forced to have only two variables, it's natural for you to not seek to use three variables.
Exactly.
And I distinctly remember having quite a lot of examples like this back when I actually invented this syntax, but they're kind of difficult to come up with now. I think there was some code in the convolution code example that I give in my book that used them.
One thing I'm thinking of is that I don't know if KamilaLisp does this or not, but reduction on multiple arrays at once is pretty neat. So you could define a reduction that takes any number of arrays, and when it's called, it reduces the function on it calls the function for the reduction on the current value and a new value from every one of these arrays. So you can take more inputs in. That's one thing that you could do.
Yes, that was actually something I was thinking of, but I didn't implement this feature. Well, there's a lot of code in the repo, right? I've worked in it for a pretty long time, and the scope of the project is somewhat big. And given that it really focuses on math, I spent a lot of time working primarily on the math utilities. There's a few screenshots you can see in the releases tab, which show you how to integrate, how to perform indefinite integration of functions. They mentioned the numerical computation capabilities of KamilaLisp. There's something with Univate teleseries that you can expand of a function. And there's also an example of deriving the Jacobian matrix and its determinant for the polar to Cartesian coordinate transformation. Using KamilaLisp, you can prove that the determinant is precisely equal to R.
Yeah.
All right. So maybe one other question. I found that there is in chapter, is it chapter or section 1.5 of the book is a chapter called function composition. And so we have the fork. Do you implement like all of the kind of, because I know you worked on reverse compose in Dialog APL. Do you have all of the kind of compose and I don't know what they're called, the top and over composition functions and even more? Or do you just stick to what's in APL?
There is an over. There's definitely an over. There is not an atop because it doesn't need to because of the Lisp syntax. There is a compose, the regular compose.
Mm-hmm.
But I didn't really add that many composition operators because I just didn't find a necessity. because tacit in KamilaLisp works slightly differently from APL, where decomposition is more explicit, right? Now that you no longer have two arguments, it's not as cumbersome to express it using the variadic fork syntax or nested forks or all you can really come up with.
As you have variadic forks, that enables you to do more with them, is what you're saying? So there's no need for a richer set of sort of different composition patterns defined by different symbols, is what you're saying?
Yes.
Interesting. Yeah, I'm definitely going to have to go and... well, here's the next question. How do people go and play around with this? Do you have to go and locally just do a git clone and build locally? Or is there a...
Well, you can go to Releases tab, and there's usually a jar file attached to the assets together with a digital signature with a PGP key.
Mm-hmm.
You can run it with a -- IDE function, which will bring you up an IDE that I wrote with Swing across like a week and a half or so. It's not very polished, but it still has some interesting features, such as project management, compressed project files, a tiling window manager, and some other features. So you can also use that. And it was also a small experiment on my side, because I was used to using RIDE for managing my APO programs, but I never really felt comfortable with the idea that my code resides in the APL interpreter. In my opinion, it makes more sense if the code is attached to the project file that is loaded by the IDE. And then, for instance, the parsed data is being sent to the interpreter so that you can execute it. This is the premise on which the remote IDE bundle of KamilaLisp works.
And so when you mentioned Swing too, it made me realize that this had to be implemented in Java, which I just went and checked and is the case. Was there any reason you chose Java as opposed to any of the other like 100 languages that you know?
Well, it mostly came to be because of the many different iterations of KamilaLisp. As you can see, it's a version 0.3.
Mm-hmm.
There was a 0.2 and 0.1 as well. So the 0.1 was also written in Java, and it featured lazy evaluation, among others. But at some point, I became kind of comfortable with the GC pressure of KamilaLisp, and then I decided that I might rewrite the whole thing in C++.
Oh, wow.
And I got a chunk of work done, but I never really liked my runtime design. I felt like I can never be really satisfied with a runtime that I can put together in like the free time I have from school and during vacation. For instance, one sore point of the language was garbage collection. I mean, obviously, if you have persistent data structures, your language is going to generate a lot of garbage, but it's somewhat easy to alleviate, right? You just need a good garbage collector with generations. The first generation has to be copying in the nursery and then subtenured space for old objects. But that's kind of difficult to implement efficiently, right? I mean, if you look at the source code of G1GC for Java, it's extremely long and somewhat complicated as well. And I never really felt good with my implementations of the C++ runtimes. So I decided to just go back to Java and experiment a bit more. And the other reason is that I feel really productive in Java. And that's probably not representative of most of the people who work with Java, I'm certain. But it feels very unobtrusive to me, and it's probably my second favorite language for actually writing prototypes in.
Really? Java? And assuming the first is APL?
Yes.
Wow. And are you, out of curiosity, because now these days I think they're up to what, Java 21? It might even be more modern than that these days. Are you in 11, 17, 21?
Generally the newest.
Wow. And is your feeling productive in Java because of some of the new features that they've added in 14, 17, 21? Or is it just because you're comfortable with the language and you like it for insert reasons?
Most definitely it's because, half is because I feel so uncomfortable with the language, right? It doesn't really make you think that much about things that are not your ideas. I mean, I really don't like to prototype when I don't know what I'm doing. I mean, it's normal to not know what you're doing, right? When you're starting out, you don't know what you're doing, and I don't know what I'm doing. So it's difficult for me to model a memory model for what I'm going to do. I don't know what object is going to own any other object, right? But I still have to model the whole object tree so that I don't have memory leaks, right? Or all the objects are alive when they need to be.
Right.
But then there is a requirements change. I think that I can implement in a better way. And then there's a problem of how do you rearrange this object tree to accommodate it for the change without having to rewrite 3/4 of it into some other style frantically while trying to also do other things.
Right.
Java doesn't make me think of all those things, right?
Yeah.
I mean,
No, definitely true.
I don't think that my Java code is like remarkably good. I think that it's actually pretty hacky, but given that I could research my ideas and verify them in such a short time span is very remarkable.
Yeah, definitely. I mean, GC language, they eliminate a whole set of challenges that you need to think about at some point, usually pretty soon. And in a sense, that's kind of similar to APL. You know, APL eliminates things like, you know, loops and indexes, and I don't have to think about that stuff. I just can work at this level, and it eliminates a certain set of problems that exist in other languages. And
Also type conversions as well for various numeric types, for example.
yeah, as well. Yeah. I'm interested. I think Rust was on the list of, not to take a complete left turn, but I guess it is a complete left turn, because Rust is a language that does the opposite of what Java's doing. They introduce a whole new facility called the borrow checker, as you know.
Yes.
For this kind of like, you know, oh, it'll save you from all these problems, but you have to now think about lifetimes and whatnot. So I'm curious, like, what are your feelings about Rust as a language compared to C or C++ or even Java and APL?
Well, if I were to prototype something high level, right? Suppose the KamilaLisp, right? I would probably choose something that's less obtrusive and generally ends up with like a minimum viable product as soon as possible so that I can see what works and what doesn't. But on the other end of the spectrum, there's the need to have C code, right? And well, the other field that I work with that I'm somewhat known for is data compression. And in data compression, there really isn't that much object wrangling as you'd think. I mean, there's a buffer, the input buffer, there's the output buffer, there's a bunch of auxiliary buffers or some simple data structures. But beside that, we don't really see that many complicated object graphs that would benefit a lot from Rust, right? I mean, Rust does, for instance, implicit bounds checking. And that would completely hammer the performance of my code. It would make it completely unusable. But to make it safe, I mean, I wrote BZ3, which is the data compressor that that sometimes outperforms mostly all the available general purpose data compressors. It's based on the Boros Fuller transform and a very simple context model. So I wrote it when I had my high school finals during the exact month, and I finished it in a single month from the start of the how I want the code to work into having a somewhat finished product. And I made a lot of bugs, but I ultimately managed to fix them. And my current feeling is that Rust wouldn't have prevented me from having made those bugs. So I'm somewhat interested in Rust, but I don't really see an application to use it myself. I'm sure that if I had a reason to use it, I would happily use it.
Yeah, well, for an interpreter specifically, it's like, so if you implement a function in the interpreter, it's going to take, some value in the language in and put some value in the language out. So all this memory management stuff, it's like, well, you don't know where your input came from. You don't know where your output's going. So you can't say anything at all about how this function interacts with like object lifetimes or anything. So Rust's facilities for, making sense of that and organizing that are just not powerful enough for an interpreter. Like, I mean, yes, you can still write safe code with Rust, and Rust has a lot of other features coming from the ML family that are pretty nice for interpreters, but the memory model is just like, that's not helpful to write a programming language with.
For instance, dialog could never be written into Rust, because if you have a compacting garbage collector, then the pointers start moving around your feet. And it's not like Rust has any facilities to stop you from making errors regarding those. And also the pointer provenance of Rust, if I remember correctly, will not guarantee that your local pointers are updated when the garbage collector decides to move some objects.
Yeah, for dialogue, I mean, I think it makes a lot of decisions just based on the fact that it's written in C. So it's hard for me to say that that's necessarily Like there are probably better approaches that you would use if you're working with a language that's not so tied into the idea of pointers.
Yeah, I mean, when I when I was going to internet dialogue, Morton suggested me to, make the array notation evaluator. And at first I thought, I can't really commit to it because I haven't seen the code and I'm prepared to be a little scared. But after I joined dialogue, this like after the first few days of interacting with dialogue code, it's actually one of my favorite code bases. It's very pleasant to work with. And despite being somewhat old, it's actually very easy to hack on. I mean, on the second and third day of my work, I had actually something tangible that you could show to someone.
Which you did show to me. But maybe but maybe it says more about your programming skills than about Dialog's code base. I'm not sure.
Yeah. I'm still shocked. Like I'm looking at the bzip3 GitHub repository, and you've got, a matrix of what looks like 60 different, Linux installations, or I don't know if they're all Linux or some of them are other. And you've got benchmarks of the Calgary corpus, the Linux kernel sources, and the Silesia corpus, and bzip3, or sorry, is it Silesia?
Silesia.
Yes, and you've got benchmarks, and you've like outperformed like every single bzip2, gzip, lzma. I don't recognize half of these other than bzip2 and gzip, but and you did this while you were in your final year of high school studying, or maybe not studying for your finals. I guess potentially you didn't need to study and you were just working on like, this is phenomenal. Like, I don't know. All I did was have my head in a book, trying to do well on my exams. And somehow you found time to not only write a compression algorithm, but like write a compression algorithm that was a successor to like an already quite popular compression algorithm, and then outperform it and a bunch of others. Like it, mind blown. Like
Compression is a little relative. I mean, for instance, my codec, by virtue of being based on the DBUT and context modeling, is somewhat symmetric, meaning that the compression times and decompression time is similar. And some people cross it out only for this reason. And well, it's true if you consider like an example of having a web server that compresses a payload and it sends it to the client. Of course, the file is going to be decompressed many times and compressed once. So it makes sense for the compression to be long and the compression to be short. But there are many examples, many cases in which compression is as frequent as decompression, right? I mean, arguably, if you have a dynamic payload on the website, it's going to be compressed on the server and then compressed on the client. It's not like you're going to send the payload multiple times if it's dynamic. And I don't really like taking a lot of credit for this because all of the ideas were already there. They just needed someone to put them together. And it was really not that difficult. I mean, for instance, the LZP algorithm was already invented by Charles Bloom. I've learned about it from his paper. So what this whole codec does is eliminating the edge cases, or rather, the edge cases meaning files with weird distributions that other compressors would work better on, and trying to equalize it as a general purpose codec. So for instance, you might notice that if you compress a text file with gzip, it doesn't really compress as well as with bzip2. And the reason for that is, well, there are many reasons, but LEPOSIF algorithms used in gzip or LZMA or whatever generally model data that has some sort of a pattern, right? Like for instance, the last occurrence of a certain letter is a fixed distance at many record points. But if you have a sentence and you encounter the letter A at some point, you can't really model where the letter A was previously seen. But if you have, for instance, a binary file, which is like a, 24-bit color image, then if the pixels repeat, they're going to always repeat on a certain boundary, right? Mm-hmm. This is also what LEPOSIF codecs exploit. So it's important to think of codecs as geared for a particular purpose, right? Like all the examples you see are mostly just corpuses or text, for instance, source code. That's what bzip3 excels at. it doesn't really excel at binary data, unfortunately.
I mean, it sounds like you're being incredibly modest. Steve Jobs took a bunch of stuff that existed and then put together the iPhone. And I'm not saying this is like Steve Jobs, but he didn't.
With his bare hands.
Yeah, he didn't acknowledge any of that prior work and was just like, well, it's a bicycle for the mind. And everyone was like, ah. And, obviously there's pre-existing stuff, but it's still very impressive. I think these days there's very rarely is anyone doing completely original work and not standing on the shoulders of giants of, previous work, etc. So caveats, made, it's still extremely impressive that, you've done this work and not only did it, but just at a time, I think when most of us were, had other priorities of just trying to graduate high school and like university applications and whatnot. I'm not sure, or we can pause if there's questions from other panelists, because I feel like there's so many different directions, because you have so many other projects. You've also got sort of the work at Dialogue that we haven't talked about a lot in terms of the array notation and quad diff and reverse compose and all that stuff. But I'll pause before we start a new topic if there's questions from the panelists that haven't been asked about the stuff we've been talking about so far before we move to a next chapter, or if someone wants to suggest the next chapter and not just leave it up to the the dictator that I am on Arraycast.
A benevolent dictator.
I'd like to think so, but I don't think a lot of dictators are thinking to themselves, well, I'm definitely malevolent,
Connor's there with the iron fist, more tacit.
Well, I don't know. I mean, it's not really a question. I just like to point out for the rest of you who haven't seen Kamila write C code in real time, because they might spur like some interesting discussions here. I've both seen Kamila write C code at the office and on my couch at home and at the Dialogue user meeting. Well, I don't remember if it was a break. I think it was a break between talks or something like that. Maybe it was in the middle of a talk or also in the middle of a talk. I mean, it's a whole different world. I don't know. I don't understand how you can program like that. And like the physical obstacles. She has a little laptop, and she's got these really long nails, and it looks very awkward to me. They can like barely push the buttons properly on the keyboard with the nails being in the way. And then I'm looking. Obviously, I don't understand this gobbledygook they call C, just weird symbols and stuff. But then she's just selecting stuff in the editor and just pasting a whole bunch of it, the same thing, and then making some modifications to each one of these copies, and then and now it runs. And that was on the couch at the user meeting. She was like, she must have been bored by or whatever that was going on at the time, so she just added another primitive to Dialogue, like on the fly like that. But I would like to know, how do you even go there? How, like, didn't even meet a person in real life that was doing programming for years, and so you're just busy with things and you get better at it, or were there influences, even though if they were virtual, that helped you to get that kind of level of programming, or you're just very clever naturally?
I think that I got so much good at programming by banging my head at it. I don't think there's a particular reason. I mean, it gets with practice, right? The thing you mentioned about working with the Dialogue code. Well, a lot of the issues that you don't see in APL pop up in C code, right? When you deal with strings in APL, you don't really care whether they're Unicode or ASCII or whatever. They just come from somewhere and you deal with them. But in the C code, as you mentioned, I kept copy pasting stuff all the time because I had a whole switch for the character type, whether it's 8-bit, 60-bit, 32-bit. And that took 400 lines of code that did the same thing.
So there's no secret. I heard a quote once that the difference between junior and senior programmers is that senior programmer is just willing to sit for like 10 hours in a row and bang their head at a problem, and they know that they can solve it. It'll just take us a certain amount of time. And a junior programmer, they get like 30 minutes into it and they're like, I probably don't know how to do this. And they give up. And that's the only difference. It's not like a matter of skill. It's just a matter of like belief in one's ability. If I keep at this, I can solve it. And I don't know if that's like actually like, I think the person was joking, but like it kind of resonated with me. It's like a lot of the times I know I can solve this, and it's like 6 hours later and I'm still, trying to diagnose some diagnostic, and then like eventually it works, and then you get up and you run around the room. But like there's no real skill level difference other than like I know within an amount of time I can get this. And it kind of, what you were saying, Kamila, reminded me of that. It's just when Adam asked you, how did you get so good? And it's just, I just banged my head at problems and and got better as time went on.
My real motivation is just that I really want to learn how things work. I mean, I really approach problems thinking I can solve it. This is simple. More, I keep thinking, I want to know how to solve this problem, right? And I feel like this is a good approach to problem solving, because if you want to learn how to solve a problem, you don't necessarily just write the code and call it a day, right? You want to learn more about the problem, about the happy paths and the sad paths of the problem, and about the variance of the problem. It's very educational and very fun, at least for me.
So you spend a lot of time like researching the problem space before you even start coding or while you're coding?
Yes.
Yeah, I mean, this is kind of you said there's no secret. And I mean, yeah, it's not like there's one thing that'll make you a great programmer that's hidden. There are 1,000 things that you should know if you want to program well, and none of them are secret, but you need to know at least a substantial portion of them. So it's, committing a lot of time to it is one thing.
When you finally did meet somebody who was a programmer in person in real life, was there anything different that happened? I mean, you'd come a long way just over the internet connections before that. So once you met someone in real life, does anything different there?
Yes, I think that once I went to uni and I started interacting with other programmers and started learning the stuff I never really had an occasion to learn, I become more well-rounded, right? I mean, it's difficult to convey, but if you're an amateur programmer like me, you generally tend to research things that you find interesting, right? You don't really care about what you should learn, you care about what's fun. And if you go to university, it's the other way around. The things are not necessarily that fun, but you should learn them.
Yeah. And if you're having fun, then you have a better incentive to go and just do it's almost like science for science's own sake here. Research about how the world works for its own sake. And then turns out you're better equipped.
Yes.
So I guess all the universities, they should just kick out all those course requirements and just say, here's a computer, go have fun, learn stuff.
Well, you need something that's fun overall, but has that kind of embeds in all the non-fun bits that you need to learn in a way that you don't notice.
Yes, most definitely. When I was working on my data compression book, I was thinking, well, I was never really that good at statistics, right? But I knew the very basics to get myself around. But I really discovered that I quite liked them. And then I went to a university course that taught me statistics. And I thought to myself that if it wasn't for the fact that I had to research this before, I would have been completely lost. And yes, that just proves your point.
Yeah, I think I've learned a lot of statistics through benchmarking because and some adjacent stuff. Like with sorting, there's some statistics around like sampling the input that you want to sort to figure out, like you can sample it randomly and figure out if certain problems will occur with some algorithm. And so, yeah, I've gotten a much better understanding of statistics by saying, well, I want to know whether this property holds, and I have this information. How do I figure it out? And that can get pretty heavy on various statistical methods.
Yeah, I also liked the randomized algorithms part of my algorithms course.
Oh, yeah.
So we were basically discussing how many comparisons does an insertion sort make in the expected case, if, for instance, the list is uniformly random or whatever. It was pretty fun. I quite like it.
All right, so here's my mind is still being blown. So you've got your first book, which we actually haven't even mentioned the title of. The title of the book is An Introduction to Functional and Array Programming. And if I was walking through a bookstore and I saw that, I'd be like, holy smokes. The Lord has like shone down the sun on me and placed a book here just for me. So that's the title of your first book. And also this is none of this. on your already amazing, basically resume of like an About Me page that lists all your stuff, doesn't mention this book. Just casually didn't make the short list of stuff that you've done, has written a book. And now you casually mentioned you have, I'm not sure if you finished, right? Do you have a second book on data compression?
Yes, I work on a small book on data compression. It mostly explains the basic methods such as static minimum redundancy codes, context modeling, impulsive methods. And well, I don't consider myself an innovator in data compression, but the reason why I'm making this book is it was just so painful to research this all myself. And I feel like I would be doing a service, I think, to a lot of people just by giving them a book which explains the concepts, gives them exercises, code samples of all the stuff that you need to know to get started. I'm at approximately 100 pages now, and I plan to work a bit during my spring break, which is coming up very soon.
And is this so actually there is a section that says talks, lectures, and papers. Is this the statistical data compression pending, or is that's a paper and not a book?
That's a talk I'm going to give on April 22nd.
So you've got one completed book and you're in the midst of finishing your second book.
Yes, I also before wrote a small booklet, which is like approximately 60 pages on how I implemented the Lisp in Malbolge, but I wouldn't consider it a book. It's just more like a funny explanation.
I guess that's what you do over spring break.
This is like you're giving me you're increasing my imposter syndrome as this interview goes on, as I discover the book section I just thought would be too much. I left that off of my About Me page because it didn't make the cut. Wow. All right. Well, the journey continues. We still have hopefully a little time left. If we're allowed to start kind of a new topic, it's been mentioned a couple times. You interned at Dialogue previously, and you worked on a ton of stuff. So maybe I'll leave it up to you. I'm super curious about reverse compose because I know Adam has referred to it in, I want to say, at least a couple of the upcoming features. When you do a Dialogue 18.0 talk, there's always a section that says for future releases. And I think reverse compose is one of those things. But yeah, maybe if you want to talk about some of the work, whatever you found most exciting when you were at Dialogue and your time there.
Well, I had a really good time. I really liked it, Dialogue. I think that it was a very good experience for me. I've learned quite a lot, and I met some people to which in some ways I look up to. I'm sure that a lot of people at Dialogue will remember me as the most unlucky intern to have ever been at Dialogue.
Why is that?
No, Kamila just keeps having incidents and accidents from public transit delays to slipping on steps and etc.
So nothing to do with the code base, the
No.
commuting and
No.
going between floors.
She did not by mistake erase our entire code base or anything like that. Nothing of the sorts. Well, you only ended up in the hospital once, right? While you were interning.
Yes.
Chaos.
Hopefully it's not because you were programming in your head or something like that, which I probably assume you do from time to time. You don't have your computer, so you're just...
She was programming in her head, but it's not because she was programming in her head.
She's always programming in her head. That doesn't matter. Yeah, Kamila, do you even program while you're programming?
I think so, yes.
Yeah, I figured.
I'll let my fingers type out the code that I have stored, and I'll work on the next problem.
Actually, it's something that I've experienced a few times where I'm faced with a problem and I intuitively know the solution, so I just type it out, and then I convince myself that it's correct because at first I don't understand it. I'm not sure it's just something weird about me or whether it's a universal experience. Have any of you experienced that ever?
No, I think you're operating at a level. At least I'm speaking for myself personally, not the rest of rest of the podcast panelists, but I think you're operating at a level, a couple of rungs, if not on a whole different ladder than where I code.
It's not an experience I'm familiar with, that's for sure.
We're sitting here in ND space looking at a bleak projection of your N plus something space.
Was Marshall, were you going to say that you?
Yeah, well, I do go sometimes from understanding it how it works in a very roundabout way to understanding, why it really works.
Steven, you're the last one. So Marshall's the closest to being on the same ladder or whatever this analogy. Or I was thinking of Interstellar, where what's that guy's name? Matthew McConaughey. He's in some other dimension that that the people can't see, and maybe that's what Kamila is here. And Marshall's up there. Kinda, I'm definitely just in 2D land or 3D land or where the rest of us are.
It happens to me with other people's code that I think I understand it somewhat, and then I get like better understanding of it, like really understand it, so I can explain it right. But my own code,
I think that I was going to say I think the difference is that I'm not usually writing it before I understand it.
That's how you should do it. Yes.
Yeah, I should, but obviously it's not working for me.
my father spoke to me about he called it Zen type programming, where he would meditate on the problem for a long time, closed eyes, not doing anything else at the time, and then you go and write, possibly punch the entire program and just run it, and it would be bug free.
I actually have heard this as well. Sean Parent, who's a many-time guest on my other podcast, I've heard stories that he also will sometimes just just sit there for hours and just like think in his head and then types it out and then it just works. And I don't know if that's like a mythical, exaggeration, but this is the second time I've heard sort of that there's a person out there that just kind of sits, cross-legged. I'm sure he's not cross-legged, but that's what I picture. It's like meditation with clouds lowering from the heavens and then this moment of I have it, and then they go type and then the code works.
I never asked my father about this, but I also had this internal image of definitely sitting on the floor. You can't sit on the chair and do this. I think you have to sit on the floor.
I have no idea.
And then you go and type or punch, depending on which year you're at.
I think I find rewriting avoids a lot of debugging. So when I've got a draft of the code, I just keep rewriting to make it look better and remove redundancies and see there's better ways I can put it. And in that process, I think I find and eliminate a lot of errors. I see connections I didn't before.
Yeah, I quite like this process too, actually.
So is this as in like revising, or is in just completely throwing out and writing it again from memory?
Oh, that's a good one. No, I'm talking about the revising. The complete rewriting is a good idea, and I like doing that too. If I think if I think, oh no, this is the wrong approach, maybe a third of it's wrong, start from scratch. But my focus is always on getting it to look as beautiful as possible. I say beautiful. I guess I'm relying on an aesthetic sense, a minimum of redundancy, looking for the connections and logical patterns in it, and code written that way is much more likely to work.
Yeah.
I did this once at Dialogue, actually. It wasn't, in fact, in APL. I think we were writing PHP for the web server. And I was sitting with one of the Dialogue staff, and I sketched out the PHP, and he very patiently watched while I fiddled and fiddled and fiddled with it and rewrote lines and broke lines in different places and moved them around until I was satisfied and fiddled with the indentation. And then it just ran. And he was like, holy cow, Batman, I didn't know that was possible.
Yeah, I do that a lot with arithmetic in particular, where there are so many different ways to write your index arithmetic. I'll try to arrange it so that it becomes clear that there's like a concept coming out of it. Like one thing that I often find is that initially I write based on an index based on the location of the beginning of the segment I'm working on. But then if I rewrite the algorithm to be focused on the end of the segment, it actually becomes a lot clearer. So I'll explicitly compute at the beginning, start plus length is end, and then do things relative to that. So that sort of rewriting, I think, yeah, that gives you a much better comprehension of what exactly you're writing.
All of this, talk about enlightened programming, for lack of a better term makes me want. I was searching it up in the last couple of minutes to see if I could see if you had done any live streams, Kamila, or something like where you've coded live or given a talk where you've done some demo. And I didn't find it. Maybe it exists online, but if you haven't, I think I would be definitely one person interested, and I think a few of our listeners, if not the panelists, would be interested to see you code, because it sounds like that you are operating at a certain level that would be inspiring, if not to aspire to, but at least to see. I'm not sure if you've ever thought about that.
Well, I'd really like doing live demos, because the golden rule of live demos is that they always fail.
Yeah, this is true.
And I've never thought about live streaming, but there's at least one person in the PyList group that has seen me program live.
Bob, you were going to say something too.
Well, I know you were talking about your abilities C programming, and Adam was talking about that. Arthur Whitney has a particular style of C programming. What's your perception of that? Is that something that you've looked at, or is that how do you feel that works with the way you program in C?
Well, when I was going to go to dialogue, I was actually scared the code will be written like that. And this is why I didn't want to commit to having done anything. But I think that it works if you're like a lone developer working on a research project or something. I've actually tried it once for my Advent of Code solutions in 2023. But I see the merits, but I don't necessarily see why would you want to write a whole program like that. It's very pretty for algorithms, right? That's for sure. But I think that when you deal with the programming parts of interacting with systems, etc., it's no longer as pretty.
So I can, and I think a lot of that is accurate. I can talk about, now that I'm working with NG&K, how I feel about that, because Nick has modeled a lot of his style on Arthur's. And I don't think it's exactly the same. But what I notice about the NG&K interpreter is that there's a fixed header of all these definitions that you have. It defines A of whatever and B of whatever, and it uses up pretty much every letter, and a lot of them twice because they're both a type and a function. So you have this fixed header, but then after that, there's just no abstraction. Everything is written out as exactly what operations you do. So like, even if there are things that are applied to multiple types, what he'll do is get the basic operation simple enough so that it fits on one line or a fraction of a line, and just write it out for each type. And this is actually seems so far to be pretty nice to work with, because everything's right there. If you understand the basic model of how this code is written, you know exactly what it's doing. And I was actually even thinking as I was writing it, in many ways, this is a lot simpler than dialogue, because dialogue has this whole memory management structure under it. And there are a bunch of kind of hidden things you have to know about working with stuff. And I guess there are a few hidden things in NG&K. There are operations that are sort of utility-like, but they operate in chunks in order to vectorize. So you have to know that, if you write all the integers up to some value, it's not going to stop at the end. It's going to go past it. But there's not like this whole underlying framework to learn about, when things are going to move around under you and how you have to register things with the garbage collector and so on. So, and I don't know if the style of writing enables that, but it kind of seems connected, that it lets you write things out in full more simply. And so then you don't rely on kind of higher level abstractions. And I think it would only work up to a point, but that's how I see the advantage.
Yeah, I can fully agree, actually, because if you look at the array style, the Arthur Whitney style C code, it's very ad hoc, right? And if you look at C code, J code, APL code, it's also very ad hoc. Look at code defense source code, and then you can see a bunch of ad hoc implementations of trees based on, arrays or whatever. But APL and the quote-unquote Whitney C programming models kind of make it less painful to type everything out ad hoc. It's kind of fun.
Yeah.
All right. We've blown past the hour mark, as per usual. I feel like our listeners would be upset at this point if we somehow landed the plane at the 55-minute mark, they'd be like, whoa, it's the goal, but it's not what we expect.
I don't know what hour mark you're even talking about. I don't get a particular mark at an hour.
Well, I usually start recording like, T minus 30 seconds before we start actually recording. So, we don't, unless if you look at the clock when we say, welcome to a Raycast, although this is like meta now.
So you actually have like a mark for an hour that you're looking
That's
at?
what I'm saying. There's nothing happens. So it says 00:59 and then it says 100 and it doesn't feel any
I
different.
mean, I assumed it was a conceptual mark.
Oh, but no, like, I guess that's the thing is, in Audacity, which is super meta, and the listener is like, what is happening here? This may not make it in at all.
So I think they're aware that we usually go over an hour.
But I actually have like a little, if I share my screen, like, blue bars, blah, 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 and like a little red line that's going, brrr, and so I can see all like a 30-second window of time. So I actually do at one point, I see, if I'm paying attention, the hour mark like slide by the screen, and now all I see is like 1:11 to
that moves in front of you. Wow. Okay.
12.
Now,
Anyways, that's what I mean by the mark. There is actually a mark, and it does go by. Yeah. Whereas everyone else is just looking at a Zoom window. So I'm not just making something up for colloquial wisdoms on the podcast.
And just to put all the cards on the table, when Connor does his intro, I look up at the corner of my screen and see what time it is. So there you go.
But I guess maybe, before we totally wrap up, is there any last questions or comments from any of the panelists, or maybe any last sort of things you want to say, Kamila? I feel like we're definitely going to be having you back at some point in the future with the rate that you are producing content and books. And you said there's an upcoming talk section. We'll make sure to, like I said in the beginning, we'll link your Dialogue 23 talk that's currently out on the YouTubes, but the future talks we'll try and keep an eye out for as well, and announce them maybe in the announcement sections. But yeah, any closing thoughts from the panelists or anything? Last questions, quick questions?
what's next? What are you going to be doing next, Kamila? I mean, you're 19.
Well, that's a very broad question.
I'm twice your age, and I've done very little, tiny fraction of the amount that you've been doing. So I suppose you could just retire and be happy with a fulfilling life that you've had and so many accomplishments. And I just noticed on your website that you have had 2 mentions on Wikipedia, not 1. So
Really? Might be the other one.
the other one was about cracking the Mersenne twister
Oh, yes. That was a really long time ago.
at age
Just
14.
forget about that.
I just thought too that 19 means that you were born in like 2005.
4.
Oh, I feel so old.
You'll get over it, Connor.
Okay, Kamila, can you implement negative number support for Quad DL?
I might work on it.
Kamila, who would you like to hear as a guest on the Arraycast?
I think that's someone I would really like to hear, but might be very difficult to actually reach out to, is Henry Baker. Henry Baker has actually published in Code Quad. He is an APLer. He did a lot of work around symbolics. He is one of the pioneers of efficient garbage collector strategies. Also someone I kind of look up to.
Yeah.
He has a Wikipedia page, American computer scientist who has made contributions in garbage collection, functional programming languages, and linear logic. And one of the founders of Symbolics, a company that designed and manufactured a line of Lisp machines.
Yeah, I think Elijah Stone has mentioned him once or twice.
Okay.
Yes, because he's related to the whole CL garbage collection stuff because of his treadmill collector and the other stuff.
Well, we will definitely reach out to Henry Baker. Henry, if you're listening, we'll be reaching out. Odds are you're not. But on like the 0.01% chance that you are, expect an email. And yeah, this has been wildly fun, Kamila, to hear about all your accomplishments that you list and all the ones that you don't list because you have too many of them. I hope we'll be able to have you back on as a guest in the future and chat about what you've been working on. And you're still in university, that's correct?
Yes.
Okay, so yeah, we're expecting great things.
No pressure.
Yeah, no pressure. I can't wait to hear about what you're doing after that. And yeah, hopefully we'll get to see you, at a conference in the future or something. I'm not sure about Dialogue 2425, but yeah, fingers crossed that we'll get to see some more talks from you, and maybe even a live stream at one point. Because yeah, this has been super fun. But before we go, we will throw it over to Bob, who will tell you how you can reach us.
You can reach us at contact@arraycast.com. Although at this point I feel fully unable to answer any questions that anybody has, because I'm just one of my favorite movies when I was a young man was Amadeus, Milos Forman's Amadeus, with the story of Mozart and Salieri. And I sit here thinking I can see how Salieri would react to Mozart. But it's much nicer just to sit and just be amazed at abilities than it is.
Which was probably what he actually did.
Yeah, possibly, because it's not as good a movie. That's true. That's probably true. But I can also see why you'd be very, if you'd worked your whole life at something, you'd feel like, I've done nothing. But on the other hand, just to witness somebody who's so able, has such abilities. Honestly, I thank you for being on. I'm not sure enjoyed is the right term to use, because I don't know that I've understood everything that's gone on. But to be witness of it is I'm grateful for that. Thank you.
Think about how many programming languages the Kamila could have mastered instead of sitting with us for an hour, right?
Yeah, I hope we've made good use of your time.
Thank you for inviting me. It was great.
No, thanks. Thank you for taking the time to be interviewed. And maybe we'll leave a couple links for those that haven't seen the Amadeus movie. There's a couple amazing scenes where Salieri comes out with this, I've been working on this for a week, and then Mozart says, and starts tinkering around, or maybe this. And there's the one scene where he plays the piano upside down just for fun. And it's there's some great, I'm sure we can find them on YouTube, and we'll link them, and that'll be the metaphor for what has happened today.
And everything that doesn't involve the relationship of Mozart and Salieri is surprisingly accurate. So they knew the history. They just chose to insert some things.
Yeah, it made those scenes were good though. Those scenes were good, even if they weren't entirely historically accurate. But anyways, thank you again, Kamila, for coming on, and hopefully we'll get to chat in the future. With that, we will say happy array programming.
Happy array programming.